All right, so this topic is Introduction to Polynomials. So we'll just say intro. All right, and then another teacher just a few minutes ago told me that these rules, these exponent rules we're going to talk about, is stuff you guys learned in the 8th grade. So you may or may not remember it, but it is important and stuff that you have to use in Algebra 2. So before we talk about polynomials, let's talk about monomials. And so a monomial is going to be a number, variable, or product of numbers and variables. So examples of monomials are just like 4. 4 is considered a monomial, or 7x, or 3x squared. So they're just going to be a single term with no addition or subtraction. Okay, and so let's write down some exponent rules. So for the product rule, if we have a to the m times a to the n, so you're multiplying and you have the same base, what do you do with the exponents? Do you guys remember? Do you add them, subtract them, multiply them, divide them? What do you think? You add them. So it's going to be a to the m plus n. So an example of something you might actually see is something like x squared times x to the 7th. You just add those exponents and get x to the 9th. And people usually remember the product rule, but the power rule you use a lot less, and it's kind of easier to forget. But for the power rule, we have a to the m, and then that is raised to the n. So it's a power that's raised to a power. Do you guys remember what to do with the m and the n on this? Multiply. So it's going to be a to the m times n. Or for example, we could have x squared raised to the 7th. We would multiply the 2 times the 7 and get a to the 14th. Right. And then for the quotient rule, if we have a to the m divided by a to the n, do you guys remember what to do? Subtract. Good. A to the m minus n. Or we could have x to the 7th divided by x to the 2nd. We would just subtract 7 minus 2 and get x to the 5th. All right, so for the negative exponent and zero exponent rule, I'm going to show you guys a pattern. I don't know if you realize this, but a lot of mathematical rules were developed by patterns. Bless you. So do you guys know what 2 to the 3rd is? 2 times 2 times 2? Anybody? 2 times 2 times 2? 8. What about 2 to the 2nd? And 2 to the 1st? What about 2 to the 0? Not 0. Not 2. 2 to the 1st is 2. Let's look at the pattern. So if we went from 8 to 4 and went from 4 to 2, what are you doing each time to go from 8 to 4 and then from 4 to 2? You're dividing by 2, right? So if I divide by 2 again, it is 1. 2 to the 0 is 1. So anything except 0 to the 0 power is 1. So I'm going to write that. I'm going to skip negative and go to 0. So if we have a to the 0, that's just going to be 1. Now, 0 to the 0 is undefined because some mathematicians proved that 0 to the 0 was 1, and some proved that 0 to the 0 was 0, and so it can't equal two things. So it doesn't have a value, 0 to the 0. All right. if we have in parentheses 7x squared to the 0? What do y'all think? This is 1 because everything except 0 to the 0 power is 1. All right, let's continue this pattern. So on the left, the exponent is going down by 1. So if I go down by 1, again, it's negative 1. What if I continue the pattern on the right where I'm dividing by 2? It would just be 1/2. Right? And then 2 to the negative 2, what's half of a half? A fourth. And 2 to the negative 3 is 1/8. Good. So this is the same as 1 over 2 to the positive 1. This is the same as 1 over 2 to the positive 2, and then 1 over 2 to the positive 3. So negative exponent just means reciprocal, or basically put it in the denominator or put it on the bottom and change it to positive exponent. All right, so if we have a to the negative m, that's the same as 1 over a to the positive m. And so x to the negative 2 is 1 over x to the positive 2. Okay, so we're going to use all those rules to do a few examples. Well, actually, we're going to do like a lot of examples. We're going to do 8 examples or 9. Okay. Yes. There you go. All right, so on number 1, when I multiply these together, the 5 and the negative 7 aren't exponents. So we just use regular multiplication rules. So we're going to multiply 5 times negative 7, and that's negative 35. But for the x's, I'm going to add the exponents, and so it'll be x to the 8th. All right, now I think on all the rest of them, we're going to use multiple rules to get to the answer. So on number 2, I can't multiply these yet because this one has a power. So the first thing I'm going to do is just square this stuff that's in these parentheses. So it's negative 2 squared? Or negative 2 times negative 2? Thank you. Now, if you're going to type it in the calculator, make sure you do negative 2 in parentheses and the square on the outside, or it'll mess up. All right, and then for the powers, when it's a power raised to a power, you're going to multiply. So that's going to be a to the 6th and b to the 2nd. Right, and then finally I can do this one like we did number 1 from the beginning. So I'm going to multiply 4 times 8. And then I'm going to add the exponents. So it would be a to the 7th, b to the 11th. All right, let's look at number 3. Sure. All right, so number 3, before I can subtract, I'm going to go ahead and do this division. So I'm going to divide 54 by 3. Anybody know 54 divided by 3, what that is? You can type it in if you want to. 18, okay. All right, and then for the m's, I'm going to subtract the exponents. So it'll be m to the fourth. And then same thing for the n's. I'm going to subtract the exponents. So it'll be n to the third. And then we're not going to talk about adding and subtracting until tomorrow, actually, but we're going to get a little sneak peek today. You can only add and subtract like terms. Are these like terms? Yeah, they're both m to the fourth, n to the third. So we have 18 of those minus 10 of those. It should give us 8 of those things. All right. Let's look at number 4. So number 4 is kind of like number 1. I'm going to just multiply 2 times 10 and get 20. And then I'm just going to add the exponents. 4 plus negative 7 is negative 3. And then most likely, like if this was a multiple choice test, like maybe the ACT or something, you wouldn't leave your answer like this with a negative exponent. And so we had an example up here where we had x to the negative 2. So we just moved it to the bottom and made it a positive 2. It's the same thing we're going to do. But the 20 isn't going to move. So the 20 stays where it is. The k is moved to the bottom, and it becomes a positive 3. Only the k has the negative exponent, yeah. And because it's negative, we can move it on the bottom and make it positive. All right. So for number 5, it's kind of like number 2 was. It's a little bit more difficult because it's got the fractions, but it's kind of the same. We want to square this first. So you can square it in the calculator if you want to, or in your head. To square 2/3, you just square 2, which is 4, and then square 3, which is 9. And then just like we did on that problem, you're going to multiply the exponents. So r to the fourth, s to the 14th. All right. And then I could just multiply 4/9 times 1/6, either in your calculator or by hand, it doesn't matter, is going to get 2 27ths. And then we add the exponents for the r's and add the exponents for the s's. And that's it. All right, number 6. We could do this in different orders. I think what's best is just to go ahead and simplify this first inside. So if we divide 14 by 7, that's just going to be 2. And then if we subtract those exponents, that's just going to be 9, w to the 9th. And then a negative exponent, a negative 1, just means flip it over and make it 1 over 2, 9, w to the 9th. All right, a couple more. I know it's hard. First day back. Stay focused. All right, so on number 7, I might teach this differently than the other Algebra 2 teachers. I haven't really asked them about it. But I'll tell you what I think is the easiest for you to do, and then you can decide. But 15 over 24, you can just type that in the calculator if you want to, or you can think about what you can reduce 15 and 24 by, and that's going to be 3. So that reduces to 5/8. All right, so on the x's and the y's, when I'm subtracting, what I do is I subtract the bigger number minus the smaller number. So on the x's, when you subtract the bigger number minus the smaller number, what do you get? 2, right? So where do you think that x is going to be? Do you think it's going to be on the top, or do you think it's going to be on the bottom? Just logically. The top or bottom? Where the leftover x is going to be? Why would you say that? Okay. The bottom. They're going to be where there's more x's. So what I do is I subtract just 12 minus 10, and wherever there was more, that's where you put your x to the second. And I don't know if your Algebra 1 or 8th grade math teachers taught it that way, but for me, that just makes more sense. All right, and then for the y's, I would do the bigger number minus the smaller number, and then where do you think the leftover y's are going to be, on the top or the bottom? Where are there more y's, on the top or the bottom? Top. So it would be y to the first on the top. This is how I do it. I just always subtract bigger minus smaller and then put it where the bigger is. 15 and 24 reduced by 3. I just reduced the fraction by 3. If you don't want to do that in your hand, you can type it in like a fraction and the calculator will reduce it for you.
Miss Skipper, we need Baxton Thompson to come to the office, please.
Okay, he's on his way. Well, 15? Okay, you typed it wrong. You did 25th instead of 24th, I think. Okay, one more. All right, so I am going to reduce this first and then raise it to the 4th. All right, so we have c over c squared. So I'm going to subtract 2 minus 1, which will be 1. And then because there's more c's on the bottom, that's where the c is going to go. And then negative 3 to the 4th. If you're going to do it in the calculator, make sure you do negative 3 in parentheses, 4 on the outside. That's going to be 81. And then c to the 4th is c to the 4th. All right, and then we are going to raise the top and bottom to the 4th. So 1 to the 4th is 1. C to the 4th is c to the 4th. All right, and then if we have a c to the 4th on the bottom and a c to the 4th on the top, what do you think is going to happen to those when you're multiplying? Do you guys know? They just cancel out, basically. So we're just going to be left with 81. Okay, we're going to do one more together. Number 9. All right, so number 9 asks you to find 2 monomials that have a quotient of negative 3n squared over m. So 2 things that you can divide and get this. So think about two numbers you can divide and get -3. There's lots of choices. What two numbers do you guys want to divide and get -3? -3 and 1? Okay, that's fine. All right, and then for n squared, we want to do n to some power divided by n to some other power that we end up with n squared on the top. So two powers that would subtract to give you 2. What do y'all think? What two numbers subtract to give you 2? Yeah, that works. All right, and then for the m's, we want to get m on the bottom, m to the first in the denominator. So we're looking for two powers that subtract to give you 1, but we want that n left over on the bottom. What do y'all think? There's a ton of right answers here. Okay, where do you want the 3? On the bottom. 3, 2. Yep, that works. So lots and lots of right answers here. Okay, so if you flip to the last page, the front of the last page, that's where the homework section starts of this packet. And like I said, it's a 3-day packet. And today, I just want you to do 1 through 8. Don't mark out the rest of them because we'll do them another day. And just hold on to this. Don't turn it in until like kind of towards the end of the week when we're done with it. All right, number 8 is kind of tough. We know that the side length of a cube can be expressed by 2x to the 5th. If the side length is doubled, write an expression to represent the volume. Do you guys know how to find the volume of a cube? If we know a side, it's just going to be the side cubed. All right, so see what you guys can figure out on number 8. It's kind of tricky.